Good afternoon.
Good afternoon, sir.
Yes, is the screen visible?
Yes,
Yes,
sir.
sir.
So finally, who are all coming to college now? I heard some 8 of you. How many? 5 of you have shown interest to come to campus. Who are they?
Rashmi, sir.
You are coming.
Yes, sir. You people will conduct me, sir.
Huh?
Yes, sir.
Okay. Fine. You are aware of what is required, no?
Yes, sir. Yes, sir.
That COVID-19 consent, all those. Fine. So coming back to our discussion, we have started with the introduction to compiler, rather stages in compilation, and those stages are 3 in number in general: lexical analysis, or tokenization, or scanning, as we know, and second is syntax analysis or parsing. Third one is code generation. So lexical analysis is what we have touched upon in the previous class. As we know, each language is having its own character set. During lexical analysis stage, we are going to verify whether the program what you have written is containing the characters which are taken from that particular character set. Meaning, if you have used any other character which is not available as a part of the character set, then that character will be considered as a not part of this particular language, and that will be projected as an error. And the process of lexical analysis is precisely to consider the given input program, divide into various tokens. A token here is defined as a least possible entity or unit that cannot be further divided. So that means every character like A, B, C, 0, 1, 2, 9, to that level, your program will be dissected and tokens will be created, and each token internally is having a corresponding number like our ASCII numbers, and these tokens will be verified whether they are part of our character set or not. If there is any mismatch, that will be shown as an error, otherwise program will be successful. That's what precisely happens in the case of a lexical analysis. And we have seen a program in the previous class. We have told that Lex is a tool that performs lexical analysis, which is available as part of Unix or Linux platforms, where using that tool, we can really make sure that whether the given data or the text or the program in general is as per the requirements of the character set of a given language. So we have seen in the previous class, if we do not write properly the program or the characters that are part of the requirement, then we may end up in a erroneous messages. So it is very, very important to define which are the actual characters, and if they are not used in the program, then anything else other than those should be marked or should be projected as a errors or a non-compliant characters. If that is the case, the programmer who is involved in designing of a lexical analyzer should be very, very careful to know best or better about the language set or the character set he or she is working to design the particular compiler. Once that is done, then we have a syntax analysis. So once you make sure in the lexical analysis stage, yes, we have used all the characters, then we have to check, okay, we have used all the characters, but those characters are there with a as per the constructs of a language. For example, I have a printf in C. I write printf. Printf is the actual syntax. But while typing, what I will do, I will write prin. Instead of tf, I will write ft. Tell me if this statement prinft will pass the lexical analysis stage or not. I've written a statement instead of printf, I've written printft. Some confusion in typing. Instead of writing tf, I've written ft. So will this be an error at lexical analysis stage, or is it okay? May I have some answers?
It will pass.
It will pass. Why?
It will just scan, sir. It will not recognize any keywords like that.
Correct. Absolutely. So it will check only T or F. It doesn't check whether T and F are in the same position. After T, F should come, or after F, T should come. That is not the work of the lexical analysis. Lexical analysis, when divides P, R, I, N, T, F separately, it doesn't care, it doesn't matter how they have been used, right? So lexical analysis stage is clear. That means just because lexical analysis stage is clear, we cannot guarantee that the written program is correct, right? And hence, we have to check the syntax analysis, meaning that the syntax of the given program. So what is syntax here? So we know that every programming language is having its own constructs, its own keywords, its own method or the structure to write a program. For example, if you take a C program will have a int for the data type, float. If you take some COBOL program, it will have a real. Instead of float, they call it as a real. So like that, each language is having its own method or its own way of defining the data. Even though the process is over, those characters, how they have been defined, is going to be difficult. In some cases, first letter should be capital, all others should be small. So case sensitive is also there. There are so many restrictions, and all those need to be maintained as they are. So syntax means whatever is defined in the language, they should be like that only. Verbatim, we use the word. Verbatim means as it is. There is no change, even one character. If the first letter is a capital, it should be capital. If third letter is underscore, it should be underscore. If sixth letter is some capital, it should be sixth letter should be capital. Like that, we have to maintain. So syntax means it is the actual crux of a given language, meaning that whatever we are going to write in the program or in the language of our own natural language, what we are using in our day-to-day communication, they have to follow like that. Otherwise, in English also, if your own language, if the syntax means the sentences are not framed properly, you will get a different meaning. So people will not be able to understand what we are telling or what we are going to communicate. So same case, even the compiler will get confused if the program is not written properly. That is the reason why syntax analysis plays a very, very important role here. So once you know that the characters of a character set are used, but next step is whether they are used in the proper format or not is the question. So that proper format is nothing but the syntax. So this is a very crucial stage while designing the compiler, because you cannot take risk here, because every component has to be checked here. Every possible way of writing a program need to be considered. If I do mistake, how do I deal? If I write a proper program, how do I deal? So all those nuances need to be kept in mind, and accordingly syntax analysis need to be done. It is very, very complex process. Probably when you go in detail, you will come to know. So that is the concept of a syntax analysis. So if you look at the diagram, actually after syntax we have a semantic analysis, right? But we are not considering at this stage, even though semantics is again very important. So what do you mean by semantics? Can any of you let me know? Normally we use the word syntax and semantics, but what is semantics here? Any example? What is semantics? Syntax is your syntax, meaning that printf means it should be printf. That is a printf. What is semantics? How do you understand the semantics? What is semantic meaning?
The logic parts.
Okay. Of course, to some extent, logic is also a very important topic of semantics. Anything else? Semantic normally is associated with the meaning of the sentence, right? Syntax is the structure. It should be like this. You and me cannot change. It should be printf, open parenthesis, close parenthesis, in between two double quotes. That's how we are going to read that. Semantics. We have to follow even one character. If you interchange, you are not going to get the syntax analysis being passed. So you will get error. We have been very much aware of this because you have written so many programs. All small errors come from the syntax. So 99% of your output of your compilation is based on the syntax. Whereas semantic errors, the errors what we get semantic, 99% they will not be shown as part of a compilation. They come as a execute. That means while runtime. Normally we say that errors are two types. One are the compile time errors, others are the runtime errors. All your syntax will be basically for a compile time errors, while your semantic errors, when semantic type of problems will be emerging as a runtime errors, meaning that the system is unable to differentiate. These things will come basically when you're dealing with a what you call some parameters or maybe some values which can be considered internally or maybe can be converted externally. All those stuff where you have some data type. For example, I have sent integer for float number. What will happen? Float will be, so your integer will be converted into float. We don't have any issue. How about other way? The implicit conversions are a one place where we have a semantic issue. So semantic problems are those which are associated with the meaning. So while writing program, we take it for granted. So real time only, when you execute the program, you will come to know how these values which I have used are going to behave. That means syntactically they look correct, but when you analyze, we have a problem. And second type of problem is your mathematical equations, which you use BODMAS rule, that plus, minus, multiplication, division. They look correct, but values are not correct. So we have some issue with the semantics. So they are very, very important and very difficult to even figure out which are the semantic errors. So they are associated with more with the type of data what we have used or the meaning with which they have been associated in the program. So they look maybe by looking at the program, they seem to be everything is fine, but when you execute that, you will get to know there might be some issue with those type of data. So that is the idea with which we have a semantics in nature. So once that is done, we can go to the code generation. So but here, as we know, since we are considering only general stages, we consider syntax stage only very important, because semantics, as we know, it is a very small stage. Even though it is very important, it is a small stage. It is, even though it is a part of a compilation, at this point of time we are not discussing that. So we give more importance to lexical analysis, syntax analysis, then straight away we assume we'll go to the code generation. So code generation is your final task, where once you confirm that your data is correct, meaning that your characters what you are using in the programming are as per the requirement of a language constructs. Second, syntax of the program is as per the syntax and constructs of the given language. Then we go for the successful compilation. Once successful compilation is over, then we'll go to the compilation means don't take otherwise. So we have just analyzed the syntax analysis. So compilation is over only after code generation is over. Okay, so this entire thing is a compilation process. So syntax analysis is done. Later we'll be providing the given source program for the final outcome, because we know as per the definition, the compiler is expected to take the high level language as a input and provide us object program associated with that source program as the output. So now code generation is the next topic. So what will happen in the code generation? So whatever syntax we have clear, the syntax will be used by the system, and that syntax will be converted back to the zeros and ones, that is the mission level language. While doing so, again, this is very important task for the compiler. So every stage is important, of course, but most of the complexity comes from the second and third stages than the first, because first stage is almost everything is ready. Just look up table. I have something already in place. Whatever I have given, just map one to one if they're existing or not. But second and third stage are more like a dynamic stage, because we as a learner or a user, we keep writing all type of programs, sensible, non-sensible. But your compiler should be able to tell us this program is not correct, this program is correct, and this is how we should be doing. All those things need to be done, means it should be more sophisticated type of piece of software. So thereby, second and third stage require lot of emphasis with respect to considering what might go wrong. If this is the case, what should we do? If that is the case, all possibilities need to be considered by the design. That's why we say compile design is very, very typical task. Very, very difficult task while developing any piece of software. Okay. Now coming to code generation. So having said that, lexical analysis, syntax analysis phases are successful. Now whatever the program is there in the high level language now will be converted to your machine level language, that is zeros and ones. While doing so, the main emphasis on code generation concept or the stage is, can I get a efficient code? So what do you mean by efficient code here? Or can I get a code where there is no duplicates? So while writing a program, you might have written int a. Just give me an example. Int a you have declared, and throughout the program you have not used a at all. You have written int a. Throughout the program, a is not used at all. So what will happen? Lexical analysis, clear. Int is valid, int a, semicolon, valid. Syntax analysis, int is a syntax definition for the data type of integer, followed by space, followed by a semicolon. Syntax is also over. So what code generation will do? Okay, I have used a and the definition section, but nowhere in the program a is used. If that is the case, why should I waste my memory? Why should I waste my resources? So what a compiler will take a call now? It will not consider a while generating the code. So it is going to neglect or omit that. That is called the optimization of the code. So code optimization is going to happen. So what is code optimization here? Whatever the code that is supposed to be generated as a part of a source program to an object program in the compilation process, we cannot generate everything that is written as in the program directly to the code. No, not required. Are not necessary as well. Why? Because as we discussed just now, some sentences you might have used, some variables you might have used, something you might have used in the program, and all those need not be part of the object program. One simple thing is, as we know, we have declared a variable or declared something, but it was never used, or it is not going to make any change in the program. It is not participating in the actual program concept. If that is the case, it is better to avoid such type of code into the object program, because that is not going to make any difference for the final code. If that is the case, we can avoid. It's like a don't care condition in your digital electronics. You might have heard, no, don't care condition. What is a don't care condition in your digital electronics? Remember or not? CO.
Sir, if there is a case of forming squad or
Yeah, so that don't care
use
is
that,
may be used, may not be used. It is not going to make any difference to the final circuit, right?
yes, sir.
Yeah, so that 0 or 1 is of no use for me. If you want, use it. If you don't want, we can omit it. But whether you use it or not, it is not going to affect the actual circuit what we have from the digital circuit. So similar to that, we have a certain data being used in the program which are not going to make any difference or sense to the final object code. That part we call it as a optimization of the program. So they will be removed or they will be omitted from the final code. So who is going to do that now? Again, the same compiler, after the syntax analysis stage, it has to consider whether should I give complete code as far as the object code is concerned, or should I stop at some part which is not going to be object code. So which is not going to be part of object code will be taken with a meticulous details. If that is going to be not included, what problem we will have. If it is going to be included, what else is going to happen? So all this coming under the optimization of the code, meaning that what we have to see here is, simply because program is syntactically correct, compiler cannot verbatim shift or convert or translate the given high level language to machine level language. No, it has to further filter the things or the program constructs or the program elements which are not going to be required as part of the final object program. So two things are kept in mind here: the efficiency of the program, meaning that time efficiency as well as memory storage efficiency are going to be considered. So memory should be also be efficient, and time taken by the program execution is also need to be efficient. So keeping both this in mind, optimization is very, very important. And we'll discuss in detail what is a code optimization when you go to code generation stage. But otherwise, at this point of time, this is a broad information that you can carry with you. That is lexical analysis or a tokenization or a scanning. All three refer to the concept of dividing the given source program into tokens or the least possible units which cannot be further divided, such that they will be checked against the language constructs, language character set. If they are matching one to one, yes, they will be considered as a part of the program, else they will be flagged as a errors. Next, once lexical analysis stage is over, then we have to check whether these characters are used in the format they are supposed to be. That's what the syntax, you know what syntax is, and those syntax will be checked again character to character without any violation. Even if one character, if you do not write properly, it will be flashed as error. So to that critical level, syntax analysis will be done, and it is supported by the process called as a parsing. We'll see how parsing is done later when you go to syntax analysis in detail. Next, third stage is code generation. Again, code generation is equally important to any other two stages what we have. It is not going to simply convert or translate the given program into object code. It is also going to maturely check whether the given code is efficient or not. So a lot of optimization will be kept in place, and accordingly code will be generated. So later we have looked at this diagram which depicts the complete way or complete process of a compilation, but majorly three stages are important here: lexical analysis, syntax analysis, and code generation. Okay, we know what is lexical analysis, we have seen, and as I told, we have two tools, that is lex and yak. So lex is a tool which is for the lexical analysis. YAC, YACC, that is the name of the tool. Probably we'll take some examples on this, and we'll try to work out, as we have seen in the previous class, how these tools are going to help us to understand how to perform these lexical analysis and the syntax analysis. So lex is a tool for a scanner or a lexical analysis, while YAC is a tool for a syntax analysis or a parser. So both we will see as we go. So are you comfortable in executing the programs? How are you doing? Whatever I have shown in the previous class, would you like to execute on your own? Are you having a software OS with you, Linux? But I want you to type and execute. I will be able to do. Did any of you try a program?
Sir, in the last class, you did one program, right, sir?
Correct.
Yeah, I tried, sir. It's working. Yeah.
Okay, you have a tool with you, OS?
Yes, sir.
Okay, you have typed that program and executed as usual.
Yes, sir. Yes.
So you know the, what you call the commands to execute all stuff. Probably the video will help, right?
Yes, sir.
Fine. Anybody else? Have you tried? Any of you? None of you have tried? Okay. Fine. So this was the program. Probably if you have time, you can note down quickly in 5 minutes. I want all of you to try this program. quickly copy that. Copied?
Yes, sir.
Yes, sir.
Fine. So this program, probably let me discuss about this structure. This is a Lex program. If you look at this program, there are 3 sections. So those 3 sections are like this. One is the user defined section. Second one is the rule section. Third one is the subroutine section or a main section. So this is the user defined section, meaning that a data section or declaration section. You can declare anything. If you look at this, what do you see from this portion which is highlighted? What type of constructs are these? Is it not a C program? What do you see here in the top? Is it not a C program?
Yes, sir.
Yes. So the declaration section or the data definition section here we have here is typically contain the characters or the constructs which we see at par with your any C language. So in data declaration section, you need not learn something new. It is as you write a C program. So hash include stdio.h int float, whatever you want to declare. Only extra here is the new construct what is required for the Lex program. So Lex program has the structure for this definition section, which is a percentage brace and ends with another percentage and closed brace. These are the 2 things which are specific to Lex. In all other intermediate thing is as per the C language. So we can go ahead with this particular definition section similar to C language. Next we have if you look at another section, I think something is missing here. We should write 2 more percentage symbols like this, that is end. You have written here in the beginning we should also write at the end. That is missing here. Probably can make a note. And what you see between these two, that is 2 percentage symbols, is called as a rule section. So we are going to define what type of characters you want. We said AEIOU is the vowel. Other than AEIOU is not a vowel. Like that, we have to be very careful in defining which are going to be part of your character set. That you can define. And do you get something from this? These 2 lines, what I have written? Can you recall something? Not able to recall. Units. Regular expressions. Remember? Can anybody recall regular expressions? GREP, EGREP, FGREP, BRE, FGRE. Yes. So this rule section has 2 parts. One is the rule, other one is the action. So rule is a regular expression or a pattern, whereas action is again C language type. So 80% here is a C language, if you observe. So only certain cases we are going to change. So this action part, which is kept in the what you call classes, character class and stuff, is going to be either regular expression or a pattern matching. So like that, for each action there is a associated rule, which is a C language content. Like that, we can write any number of rules in this, but it should be enclosed with 2 percentage symbols in the beginning and 2 percentage symbols in the end. So this is the rule section. At the end, we have a last section, which we call it as a user subroutine section or a subroutine section or a main section. Here it is again completely a C program construct. Only extra here is YYLEX. So YYLEX is a function which has to be at the first line of the program. If at all, processing has to be stopped. If you observe in the previous lab, when I have written this program, I had written one line before this, printf, enter the text. So if you want anything to be given as a message like that, you can use. But if you want a processing to start, that processing should be started only after writing this line. Suppose if I write printf, these 2 statements before YYLEX, you will not get any output. That means this is a function which will trigger the lexical analysis to be performed. So this function is a important function for a lexer to start processing. So anything that you write after this only will be executed in line with the lexer. Anything you write before that, it is only like a messaging. It cannot be executed as per the requirement. So better you make sure that you start with YYLEX first, then write all other things what you want. This is a simple program. We can write like this any programs. We'll see how the programs can be written later. Once program is written, now we have to compile the program. So to compile the program, first one is I have written this program as a.l. So now you know how to create the program using VA or gedit. After that, lex. There is a command by name lex. We can compile this program. So once you compile this program, you will get a program by name lex.yy.c. That means the result of the compilation here is nothing but a new file lex.yy.c will be generated. So that means lex program is finally converted into a C program. So that's what you see. Most of the constructs are related to C language. The outcome of a lex a.l or lex of any language, any lex program is nothing but lex.yy.c. That means it gets converted into a C language. If you open this program while executing, you can see that you will see whatever you have written here. This part And this part you will see. You can open this and see. You will see whatever you have used in the user subroutine section and the user data declaration section. All those things can be seen. Later, since it is a C program, you can compile as if it is a C program. So CC, GCC, at the end, you write this extra because this is a Lex library. Since it's a Lex program embedded into C, I need to submit the Lex library. So -LL stands for the Lex library. So when I give Lex library, this program will be compiled properly. After everything is over, when there is no error, as usual, you can execute using ./a.out. This is how Lex program is written. So if I give some more programs, how will you be able to execute? I want all of you to execute. You want me to execute and show, or you will be executing on your own? How it is going to be? But I want all of you to have a hands-on, to just understand. Though it looks like a small shell program, but you need to feel. Is it possible to all of you to execute at your end? And Manjunath was telling we can use some online tools. Manjunath, can you try that?
Oh, yes, sir. I'm trying it actually.
Okay. Could you able to get some?
As of now, no, sir.
Okay. No. Did you try that program or you need to try?
Yes, sir. I have tried in few online.
Yeah.
I couldn't run anything.
That program was not working?
No, sir.
Okay. Maybe they don't have that support for Lex tool, I believe.
Maybe, sir. I'll be trying a few more today or tomorrow.
Okay. Try and let me know. Otherwise, anyhow, I can execute and show, but that will be one-sided. But I want you to try, each of you. Okay, fine. So this is about the Lex program, which is a lexical analysis stage. Is that clear now, how lexical analysis is done? What is the need for it? In general. Fine. So next stage is syntax analysis. As I said, syntax analysis is to verify whether the given statement of the program is in line with the constructs of the language. C language will have its own construct, C++ will have its own construct, Java will have its own construct. Like that, any other language will be having unique constructs, or maybe some common might also be possible. But when you're giving to that compiler, you should be following that compiler construct. So keeping that in mind, syntax analysis need to be verified. To facilitate syntax analysis, we create a parse tree. We write a parse tree because internally the system will generate a tree. So parse tree means, syntax means what? You should be having a complete data. When I say printf, 2 parentheses, double quotes, then one parenthesis if you write left parenthesis, if you do not write the matching parenthesis on the other side, it has to be given as a error. So how do you check that? So that is how it is going to be used. So like that, a parse tree will going to match whether you have a proper characters being used, like a parenthesis left as well as right, quotes, left quote and double quote on the right side. So all these matching things will be checked, or anything for that matter, to help compiler to understand a proper syntax analysis is carried out. So parse tree is going to be an important tool that is going to come as a handy tool for the syntax analysis. So parsing is going to be done, and parsing will be done through the parser. So we have a YAC as a parser. So YAC, we have a name by name YACC. This is also similar to Lex. It is also a tool which is going to be part of your Linux or Unix, which will be used for performing or a parsing type of activities. We'll take some examples and see how YAC will. So Lex is one type of tool for lexical analysis. YAC is another type of tool for the parsing, and put together we can use for any compilation process as a simulator to learn. So, but this is what is going to help us to understand the process behind the compilation. But when you go for compiler design, it is going to be more complex than we speak here. So, but you should have a glimpse of how the process is going to be carried out or involving these lex or the act. So lex and act will only give us a simulation type of information how we can do. But if you write a bigger programs or complex programs in lex and act, probably we can visualize these two stages of a lexical analysis and syntax analysis as well. Okay, so this is about the first two stages. Of course, in third stage, we know the code generation. The code will be generated, and as we know, code will be optimized. So this is the basic introduction behind the three stages involved in general as far as the compilation process is concerned. So any doubts till this?
No, sir.
Fine. Okay. Having said that, we have these three stages under the compilation process. Now we have to go in detail about each of the stage, that is lexical analysis. We know lexical analysis is performed by dividing, but how to divide that? And we have a tool, but we cannot use tool always, no, because we have to understand as a layman now how compiler design is done. Similarly, syntax analysis, we said parsing, parser. What is a parser? How parsing is done? How to generate a parse tree, that we have to see. Second, code generation. What is a what you call optimized code generation or machine dependent code optimization? All those things will be working. So these three stages will go in detail now onwards. Okay, so first stage is now lexical analysis. Will go in detail. So before we go to lexical analysis, probably we should look at the concept of a grammar. So just read this concept, what is being shown on the screen. Meanwhile, I will take attendance. I'll come back to you on this. Your attendance. Asta?
Present, sir.
You've been irregular, Asta, for last week?
Sir, I was not well. That's why.
Okay, okay. Abhinav? Aishwarya?
Present, sir.
Ambarish? Ambarish?
Yes, sir.
Anu?
Present, sir.
Arbaz? Arjun?
Present, sir.
Ashok?
Present, sir.
Vinita?
Present, sir.
Bhargavi?
Yes, sir.
Kavisha?
Present, sir.
Chaitra?
Present, sir.
Chatterjee?
Present, sir.
Diksha?
Present, sir.
Deepika LG?
Present, sir.
Deepika MB?
Present, sir.
Murli Krishna?
Present, sir.
Gangubai? Guria Kumari? Arshit?
Present, sir.
Dunjar Singh?
Present, sir.
Kavya? Kishore? Lata?
Yes, sir.
Manisha? Manjunath?
Yes, sir.
Nayana?
Present, sir.
Nilanjan? Nishant?
Present, sir.
Pavitra?
Present, sir.
Maithili?
Present, sir.
Priyanka?
Present, sir.
Pavan Kumar? Akash? Rajeshwari?
Present, sir.
Rakesh? Ramya?
Present, sir.
Rashmi?
Present, sir.
Ravi Shankar?
Yes, sir.
Rizwan?
Present, sir.
Vishal?
Present, sir.
Savita?
Yes, sir.
Shruti?
Present, sir.
Present, sir.
Sneha?
Yes, sir.
Spurti?
Present, sir.
Srinidhi,
Present, sir.
Srinivas,
Present, sir.
Sunil,
Present, sir.
Vaishnavi,
Present, sir.
Vinny,
Sir, Kavya present, sir.
Kavya. Okay.
Rakesh present, sir.
Okay. Okay. Fine. So hope you have gone through this screen. So in the lexical analysis, we use the concept of a grammar. It's not a grammar of our English grammar, even though the name is same. We have a very important and a very interesting topic called as a grammar in compiler design. I don't know how many have heard about finite automation. Any of you heard about finite automata? Automata theory, finite automation, formal languages and stuff like that. Did you hear somewhere during your
Sir.
graduation?
Yes, sir. In theory of computation.
Okay, you had. So you know what a formal language or finite automata, n-tuple, 4-tuple, 5-tuple, grammar. So if you are well versed, it is easy for you to understand. Anyhow, we'll continue this particular thing in the next class. So probably next class we'll touch upon what a grammar is and what type of grammar is important from the compiler design point of view. Out of so many available grammar structures, we use BNF, that is Backus Naur form. That is the one what we follow. Later, given the automation, how we are going to use the automata theory to figure out whether the characters what we have used are as per the what you call the scanning requirements of a given programming language. So probably those stuff we will be seeing. Tomorrow's class will be very important, and because those diagrams, if you have already studied, fine. Otherwise, it is very difficult for you to understand. So better you make sure you are present with some pen and paper, so that as we discuss, you will be able to practice and understand those. I may give some 2-3 exercises as well tomorrow, so that we can understand better. So we'll meet you in the next class with the grammar section. Thank you.
Sir,
Yes.
sir, only 5 members sustain us, sir.